team. Today we're going to be learning about nuclear radiation, a physics topic. Curious? Data question 1. What is found at the centre of an atom? 15 seconds. And the answer is the nucleus. Question 2. What is found inside the nucleus of an atom? Time starts. Inside the nucleus, we find protons and neutrons. Next question. How does an unstable atom become more stable? An unstable atom becomes more stable by giving out radiation from its nucleus. And that is why we call this type of radiation nuclear radiation. Okay so far? Well, let's have a look inside the atom. The centre of the atom is called the nucleus, and flying around the nucleus on shells or orbits are things called electrons. Now let's have a look inside the nucleus. Inside the nucleus we have two subatomic particles, things found inside the atom. And if we look inside the nucleus, you should be able to see protons, the blue ones, and neutrons, the red ones. In real life they are not coloured like this. I've just done them different colours so you can see them on the diagram more clearly. Now I wonder if you can recall the electrical charges of a proton, neutron, and electron. Have a think for a moment. Protons have a +1 charge. They are positively charged. Easy way to remember it, P for proton, P for positive. Next, we have electrons. And electrons have the opposite charge to protons, so they are negative or -1. Neutrons, however, have no charge at all. That is why they are called neutrons. It's very similar to the word neutral. Hey people, are you actually watching and listening attentively? Well, let's see if you are. You should be able to state the charge of each subatomic particle. 15 seconds. Answers coming up. Protons are positive, electrons are negative, and neutrons are neutral. I sincerely hope you got all three of those. If not, pay closer attention to the next section. We are now going to learn about the three types of nuclear radiation. The first one is called alpha. Alpha has a symbol which is a Greek letter. It looks like this. The next one, beta, also has a Greek letter for its symbol and it looks like this. Gamma, again a Greek letter for its symbol, which looks like this. Wow, they look really different from each other, don't they? That's because they are. If we start by looking at alpha, it's quite a bulky old fellow. It's made up of 2 protons and 2 neutrons, and it's identical to the helium nucleus. In contrast, beta, this little fellow here, is just a fast-moving electron that is fired out from the nucleus of an unstable atom. And finally, our friend gamma here is not a particle at all. It is just an electromagnetic wave, also known as EM wave. Although they are very different in their structure, They do have something in common. All three types of nuclear radiation come from the nucleus of an atom, and all three give out a lot of energy and help to stabilize the atom. Next task for you is to try and work out the electronic charge of each type of radiation. So does each one have a positive charge, a negative charge, or is it neutral? 15 seconds, starting from now. And here are the answers. Alpha has a +2 charge because it contains 2 protons. And if you remember from earlier, protons are positive. Beta has a -1 charge because beta is just made up of a single electron, and electrons are always negative. Gamma, however, has no charge. It is not a particle, therefore cannot carry a charge. It is just a wave. How are we doing? We now need to look at the characteristics of each type of radiation. And we're going to start with alpha. Alphabetical. Alpha. Our first guess then is alpha. Now alpha could be represented by this large fellow here, Leoprene. Say hello, Leoprene. So Leoprene is bulky, he's heavy, and he's slow moving. Well, actually, in real life, this cat's pretty fast, but for our model, he's a slow mover. Alpha particle, imagine him. Welcome to the beta bunny. Beta is smaller, lighter, and faster moving than the alpha. And there's more to this bunny than meets the eye. Behold! Yes, he actually lights up as well. Real beta doesn't light up, but this beta bunny's got something extra. Now I'm going to model gamma using my laser pointer. So for this, I might turn the lights off. Gamma is extremely fast moving. In fact, it moves at the speed of light. No mass at all because it's not made of any particles, and it's highly penetrating, which means it can cut through materials like a knife through butter, or vegan spread if you prefer. Let's go over those characteristics again. Alpha radiation is slow moving, short range, it can only travel a few centimeters through air, is heavy, not very penetrating, and is stopped easily by skin or a sheet of paper. However, alpha is highly ionizing. And don't worry if you don't know what that word means yet. I'll go over that shortly. Remember the leopard. He's heavy, he's bulky, he tends to smash into things. So he's very ionizing. Aren't you? Ionizer. Beta radiation is a fast-moving electron from the nucleus. It has a medium range of about 1 meter. Beta travels 1 meter. It is virtually mass-free, moderately penetrating, stopped by a sheet of aluminium, and is also moderately ionizing. Now you may be wondering how an electron comes from the nucleus, because at the start of the lesson we had a look at the structure of the atom and we said that electrons are found on orbits on the outside of the nucleus. This is true. However, during nuclear decay, what happens is one of the neutrons inside the nucleus breaks down spontaneously and becomes a proton and an electron. And in this process, a lot of energy is released. So the proton stays in the nucleus, but the electron is ejected at very fast speeds. And that electron that comes from the nucleus is known as beta radiation. Finally, gamma radiation. So gamma radiation is very fast moving. It has infinite range in air, which means it can just go on and on and on unless it is stopped or absorbed by a material. It is mass-free, very penetrating, and is stopped by thick lead or concrete. It is only weakly ionising. There's a lot of information we've taken in there, everybody, so it is time for a learning check. It's very straightforward. You'll have something to look at on the screen and you need to decide if it's alpha, beta or gamma that it's referring to. Just shout your answers out, doesn't matter if you get it wrong, it's not like anyone can hear you during lockdown, so just have a go. First one, have a look at what it is approaching the sheet and then decide what the sheet is supposed to be representing. 3, 2, 1. It's beta. So you've got a sheet of aluminium and a fast moving electron. Next one. Take a look. Alpha, beta or gamma? 3, 2, 1, 0. The answer is gamma. The clue was in the waves. Remember, gamma is not a particle, it is electromagnetic waves. Next one. Alpha, beta or gamma? 3, 2, 1. This is the symbol for gamma. Well done if you got it right. Next one, take a look at this. Look at the particle, look at the sheet. 3 seconds. 2, 1, 0. This is alpha. You can see it's a very bulky particle, 2 protons, 2 neutrons, and it's heading towards a sheet of paper which stops it. Next one, alpha, beta or gamma? 3, 2, 1, 0. This is the symbol for alpha. Let's go over this again. So alpha is a bulky particle and it can be stopped easily by a sheet of paper. Beta is a fast-moving electron which can be stopped by a sheet of aluminium. Gamma is not a particle but electromagnetic waves and can only be stopped by thick lead or concrete. What does ionising mean then? For an atom to become an ion, the atom either loses or gains electrons. In the example pictured, we have a sodium atom, and if it loses its outer electron, it's become a sodium ion. This also means it now has an electrical charge of +1. So if an atom loses or gains electrons, it becomes electrically charged and we call it an ion. Unfortunately, ionising radiation can damage our cells and DNA and hence cause bad health effects like cancer. And that is why we have this hazard symbol to warn people if they are in an area which has high levels of ionising radiation. Time for our final checkpoint, everybody, and it's your favourite, the multiple choice quiz. Okay, this is going to be fairly quick fire, so get ready. Call out your answers. Question 1. The centre of an atom is called the alpha, nucleus or proton. 3, 2, 1. Correct answer is nucleus. Question 2. The subatomic particle with a negative charge is the electron, proton or neutron. 3, 2, 1. Electron. Number 3. The most penetrating of the 3 types of nuclear radiation is beta, gamma or alpha. 3, 2, 1. Gamma. Number 4. Which type of radiation would be the most dangerous inside the body? Alpha, beta or gamma? 3, 2, 1. Alpha. This is because alpha is the most ionising of the 3 types. Question 5. Which type of radiation is a fast-moving electron from the nucleus? Alpha, gamma or beta? 3, 2, 1. Beta. And final question, number 6. Which type of radiation is identical to the helium nucleus? Beta, gamma or alpha? 3, 2, 1. The answer is alpha. Lesson over. Well done everyone. I know that can be quite a hard topic. How did you get on? A big thank you to our friends, Leoprine the leopard and
the white rabbit.